Hi folks, Thomas Henson here with thomashenson.com, and today is another episode of Big Data, Big Questions. And so today I'm going to continue our series where we talk about IoT, but I want to talk about why IoT engineers use the publish subscribe pattern. So we've talked about it a little bit in other videos about that pattern, but I want to specifically break down what it is and why engineers are using it and what some of the disadvantages are and what the main advantages to using that publish subscribe architecture pattern is. So find out more right after this. Welcome back. So before we jump into why data engineers and why IoT engineers are using the publish subscribe pattern predominantly for those IoT or Internet of Things workloads, I just want to say if you have any big data, big questions, make sure you put those in the comment section here below. Throw it out on Twitter using hashtag big data, big questions. Or find it on my website. You can go, there's a little place where you can go in and send me an email and I will answer those questions here. Also, make sure you subscribe so that you never miss an episode about data engineering, interviews, demos, what's going on in the community. So I want to take a step back and talk a little bit about what the publish subscribe pattern is. I know we talked about it a little bit when we were talking about IoT and some of the things for message brokers and how those things work, but I really want to take a step back and explain what that pattern is. And so the publish subscribe pattern is a way for publishers and subscribers to interchange messages. But instead of having it where they're strongly connected, this is actually a decoupling. So using this pattern, you have a message broker in the middle that's actually going to dole out those messages as they come in. So think about your publisher as being my garage door. So my garage door, whenever I come in, it'll send out a state. It'll say that it's either open or closed. So that'll be my publisher. So that publisher, whenever the garage door is open, it's going to send a message saying open out to the message broker. It's going to sit there in that queue. So think of a queue as, Kafka or RabbitMQ or the other message brokers we've talked about. It's going to sit in that queue there. And then a subscriber, so say I have an application that keys off of that, it's going to subscribe to that message. And so it's going to subscribe to that message so that it's able to send it and be able to receive that information from the broker. So that's the decoupling of it, right? So if my message broker doesn't get any more messages or, my publisher, so my garage door is down, it's decoupled that, so it's not making my application in a state where it's not working, right? So this gives you the opportunity, so you've got that last state from it, and so the last state was updated that the garage door was open, but your application's still working because your application probably has other functionality, right? It has other data points, other messages that are kind of working with it. So it doesn't take it down. The other cool thing about it too is this gives you the ability to scale. So in a publish subscribe pattern, you can have one publisher, so my garage door, that's one publisher, can have many different subscribers. And those subscribers are able to just subscribe through the message broker. So if something breaks down with one of my subscribers, it doesn't matter to my publisher because the publisher has no idea who subscribed and the subscriber has no idea about the publisher, right? They all work through that broker, and that's where message broker queuing system really gets its name from the publish subscribe pattern. So why is this pattern so popular for IoT engineers? Well, it's very scalable like we talked about. So we've talked in the past about by 2020 we're talking about having 20 billion, maybe even 30 billion different devices worldwide with an IP address. And so all these are going to have to be connected to the internet in some way to be able to send out data and send out information. And so think about all the different applications that are leveraging those. You're just going to need something that's very, very highly scalable. But like with anything that we use, there are trade-offs, right? So what are some of the trade-offs, for it? Well, one of the things is it can be a little bit spotty and a little slow, right? So when we talk about, being able to stream in data and be able to do data analytics on a fast scale, using this pattern may be a little bit slower, right, than if you had some kind of dedicated where we weren't decoupling it, because we're going to an intermediary, right? So we're using that message broker kind of as the middleman, and so that middle architecture, it does add some latency. So you'll see that, but the trade-off for the scalability really outweighs that. So, and then another concern, and this is a concern for everything in IoT. Probably should do another video series just on this, but security, right? I talked about the publisher has no idea about the subscriber, and the subscriber has no idea about the publisher, right? The subscriber just says, "Hey, I'm going to the message broker. I trust that this is it." So you need to be a little more cautious about security in these architecture patterns, and that's where we're starting to see some encryption, and we're starting to see some things around blockchain and other ways to be able to encrypt that data. So start looking for and make sure you're doing your best practices with that security, but understand that we're still in a stage where we can manipulate. So you could have a subscriber who's being manipulated by a publisher that's not really my garage door, right? It could be, it could say, "Hey, let it go in," right? The door says it's open. So now if we start thinking about, okay, how does this go worldwide, right? And how are these applications all kind of interdependent? Think about, I need that publisher to send that data that, hey, the garage door is open. Well, say that that's the only piece of information that is used for my automated car. So my automated car is coming in, it's driverless, we're in the future now, it's trying to park in my garage. Well, if somebody imitates that, right, and says, "Hey, the garage door is open," but it really wasn't open, and then that's the only piece of information that my automated car uses to park in the garage, well, we're in trouble, right? Because I'm gonna have to buy a new fender for my car, and I'm gonna have to buy a new garage door. So those are some of the things that can happen from a security perspective. We're really trying to make sure that we're planning for that. Obviously, in that situation, we're hoping that the automated car is not only dependent on what that subscriber, the information the subscriber is getting from the publisher, because then, there are things. What happens if the power's out, right? What happens if we have a spotty internet connection? So those are some of the trade-offs and some of the things that we see with these applications. But for the most part, we're going to have to do that, right? Because we're going to have to be able to scale the data. So that's all I have today for Big Data, Big Questions. Make sure you subscribe, and if you have any questions, ask them. I'll answer them here for you. Thanks.